All right, what's up, guys? So this video, page 3, continuation from the previous two. The focus of this video is to continue that conversation of what does a derivative look like, but not as a process that yields a number, like a specific value for a slope at a specific location, but more about like a function. Like, can we describe all possible like slopes of a curve and write that description in function notation? The derivative at x equals x or something, whatever. But the goal of the function is to find, or the goal of this is to find a function that we're going to say that's the derivative. So we're looking for some sort of x expression. Still going back to the limit definition. The limit definition, well, that's, I didn't realize my fingers moved around that much in the video, but the point being, like, we're using the limit definition formula. A lot of that work has already been done, but you used 2 in page 2 notes, and now we're using x instead. Like, x can be anything, and if you want to evaluate it at 2, you can. It's right there, it's ready to go. Some things that actually happen in this moment, by the way, I'll keep 3x squared plus 2x as a reminder. That was part of what happened during the lesson. We came back to it at a later point to find the derivative at a later point. But the point right here is that students will make an algebra mistake, specifically an algebra mistake where they don't evaluate the function correctly, or they forget about how they're supposed to factor or FOIL, not factor, but FOIL and then combine like terms and cancel if cancellations are possible, which they are. That's the way these problems are designed to do. So expanding x plus h squared and then multiplying through by 3, of course, all of that's still in the numerator, and algebra steps are what's happening at this moment. No calculus has been happening. You have to use the limit as h goes to 0 notation all the way through until you can finally make some cancellations and factor and divide out. So there's a step there that I didn't really show, but I'm factoring and dividing out the h from everything, and I'm left with an expression 6x plus 3h, which, if h goes to 0 when you have no more problems, then I guess 6x plus 0, 6x. 6x is the function that is the derivative of 3x squared. We continue the conversation with this idea of trying to recognize a pattern, right? The whole point of using the limit definition for a derivative is to eventually be able to start seeing connections. There should be some patterns that pop out that we can use. Maybe they're graphical, maybe the goal is they're algebraic, but we want to make sure you see these things. Okay, this is page 3, and we did go through page 4, so are you ready for more? See you in the next video.